Everyone, and welcome to our NMIS Insights on Demystifying Industry 4.0 for manufacturers. I'm just going to begin with a bit of housekeeping. So this webinar is being recorded and it will be made available later on our YouTube channel. Your microphones and webcams will be turned off during this session. And you can type your questions throughout the session in the little chat box. If you have questions directed for someone, if you could start your question with Grant Payne and what the question is, or if it's just a general question, keep that as a general question. There will be time allocated at the end of this for the speakers to answer your questions. If you're tweeting, please use the hashtag NMISinsights for any questions on Twitter and we'll pick those up. And at the end of this, we'll send out a survey and we'd be very grateful if you took some time to fill that out and send it back to us. So today your hosts are Richard Miller, who is a senior R&D engineer in the NMIS digital team. Myself, I'm a manufacturing engineer and the project lead on the AMBATS project at NMIS, and Tom Gillespie, who is a SMAS practitioner from Scottish Enterprise. So just to introduce you to what is the National Manufacturing Institute Scotland. It's a group of industry-led manufacturing research and development facilities where research, industry and the public sector work together to transform skills, productivity and innovation, and to attract investment and make Scotland a global leader in advanced manufacturing. So NMIS will increase productivity by reducing barriers to innovation. It will stimulate investment and increase manufacturing competitiveness, catalyze job creation and strengthen supply chain links, inspire and attract and equip current and future workforces with the skills they and business need. Work with manufacturing businesses of all size and multiple sectors, providing benefit across the whole of Scotland. So how NMIS is structured is through the One Scotland team. So it's operated by the University of Strathclyde, but we're also supported by the Scottish Government, Scottish Enterprise, Highlands and Islands Enterprise, the Catapult High Value Manufacturing Network, Skills Development Scotland, Remanufactured Council, the Scottish Funding Council, and the South of Scotland Enterprise. How the structure of the national manufacturing looks is split across what is open just now, what is in development, and what will be opening in 2022. So what is open now, the Advanced Forming Research Centre and also the Lightweight Manufacturing Centre. We do have temporary workshop space that's in development and being used at this moment in time, and we also have a digital outreach via the NMIS network. So the core elements of NMIS once it is being pulled together and we have the physical building will comprise of the digital factory, the collaboration hub and the Manufacturing Skills Academy, and then pulling that in together as well. The specialist centres will include also the Advanced Forming Research Centre, the AFRC, and the LMC, the Lightweight Manufacturing Centre. I'm now going to pass you across to Tom Gillespie for the first presentation in this webinar. Over to you, Tom.
That's great. Thanks, Grant. Good morning, folks. And as Grant says, thanks very much for joining us today. Next 10 minutes or so, I'm going to give you a brief introduction to the SMAS Industry 4 assessment process, a little bit of background, how the process came about, how it operates, and some of the potential outcomes that we would expect from such an assessment. So first of all, just in case, I know some of you are well familiar with SMAS and what we do, but just in case there's anyone in the call who isn't, who or what is SMAS? SMAS is the Scottish Manufacturing Advisory Service. We're part of Scottish Enterprise, Scotland's economic development agency. We're made up of about 25 to 30 manufacturing professionals from a variety of backgrounds, generally from about 10 to 35 years private sector experience prior to joining SMAS. Our focus is very much on delivering company-specific support or advice or projects, and very often that can be either through some of our SE or third-party specialists. Our four main target areas have traditionally been operational excellence, for example, Lean and Six Sigma, business culture and leadership, supply chain development, and most recently we have added in the Industry 4 I4 offering to our portfolio. One of the key drivers in terms of SMAS becoming involved with Industry 4 was very much in response to the government's concern about, the well-documented Scotland and the UK's productivity challenge. If you take that a couple of years back, that's from 2017, you can see Scotland in red there, positioned kind of at the bottom end of the second quartile, which was actually a slight increase on where we had been. But nevertheless, moving to the first quartile would have significant benefit for the economy and jobs in general across the country. As such, the evolving Industry 4 scenario could be seen, both as an opportunity or a risk. Was it indeed a real opportunity to get in early, as it were, and really start to close that gap? And indeed, if it was such an opportunity, if we missed the boat, would it drive us back into the third and potentially bottom quartile? As a result, SMAS was asked to look at how do we start to engage in I4? How do we involve our companies in I4? And in particular, how do we raise awareness of some of the new technologies and business models that are possible using Industry 4? As such, we created an Industry 4 review, which, as you'll see there from the graphic, looks at not just the smart factory side of things, but potential business models. And it's pretty much an overarching process that, rather than just, technology for technology's sake, a big part of the process is really to start to identify with companies where targeted investment would bring the greatest difference to them in the short and medium term. Third part of the review is very much about assessing how ready a company is to deploy such technology. We realise that not all companies are the same. Everybody's got their own quirks and historical issues that they need to overcome. Do companies have a continuous improvement culture? Do they have the basics in place in terms of employee engagement? And indeed, even the IT infrastructure. Company can be really keen to undertake investment and develop, but some of the basics in terms of even broadband and such like may not be there to support initially. So as I say, we developed the Industry 4 process, review process within SMAS, and that's a quick overview, and I'm going to touch in the next few minutes on each section. Generally, there's an initial meeting or call with the company to outline the process, agree dates, and understand who's going to be attending on behalf of the company. Day one is very much about the diagnostic, understanding where companies are and where they need to be. Day two being a road mapping session in terms of working through, okay, how do we start to bridge some of those gaps? And finally, we'll close out with a road mapping and agreement session in terms of what actions, who's taking what actions, and what timelines are associated with these. So as I say, day one is very much diagnostic is at the heart of day one. However, we start off with very much an introduction to Industry 4. People even within similar business, within the same business, have very different understandings in terms of what Industry 4 is. We go right back to basics from some of the definitions. We talk about some of the potential benefits of implementation. And our digital transformation specialist who accompanies the SMAS practitioner on these will generally take the company through an indication of how some of the technologies could be applied, some good examples, and starts to discuss what technology they have on site at the time. We then pass the baton over, if you like, to the company, such that we understand, what is the company's focus currently? What is their current strategy? What products and markets are they looking at? Is it, the existing products in existing markets, new products into existing markets? Are they looking to diversify into perhaps new products into new markets? And close that section out very much with what are the current challenges? What are the current opportunities? And that really opens up discussion in terms of helping the SMAS practitioner and the digital transformation specialist from SE understand where the company's positioned. The second part of the day, as I say, is very much about the diagnostic, and this is where we start to understand where the company is today, and against certain criteria, where they need to be. And a big part of what companies benefit from this in terms of the feedback they give is the discussion that actually takes place. In many ways, the scoring is actually secondary, but it's the debate, the discussion, and the opportunity to understand collectively where the company needs to head. As I say, the diagnostic covers 6 key themes. They are business strategy, leadership and people, capital assets, technology, data management, and supply chain and system integration. So pretty much there's about 30 questions, and we spent whatever time is required going through each of these and opening up that discussion in terms of where the company are today and where they need to be in a kind of 3 to 4 year time frame. That's just one example there to share with you from the data section. So for example, there on data visualization and analysis, you can see there on the left-hand side, the company scored 1, not yet planned. So they don't have a comprehensive analysis in real-time data. Now they might well decide, yeah, we need to get to a 3 or we need to get to a 5. The scoring in many ways is almost secondary. The discussion and the intent are probably the key things that will come through that. So we have that discussion, we have that scoring, we cover the 6 sections, and ultimately through the process, we will come up with a radar chart like that at the end of the session. It will show against each of the criteria very quickly where the companies are and where they need to be. And while it would be easy perhaps to look at the biggest gaps are not always the priority for the company, and this is where we really need to understand where the company is putting its strategic focus, because sometimes going from a 3 to a 4 can be much more of a priority than say a 1 to a 4. But that's very much specific to the company and what they're looking for. So we'll take that information away. Usually about 3-4 weeks later, we'll get you a report sent out, which will include the radar chart and any findings and such like. We then set up the road mapping workshop on day 2, which again is usually a best part of a full day session. And it's very much, as you can see there, a kind of brainstorming, idea creation, discussion, trying to say, how could we close this gap? What are some of the things we need to do? And you'll see there's an example of the technology section. There's 10 subsections there. There's actions on kind of, you would call 3 hotspots. So we're not looking to complete, there's a limit in terms of the resource and funding that companies have. We recognize that. So we don't try and just fill the sheet. It's very much a targeted, in this instance, for example, it's cloud computing or process automation hardware that are taking the priority. So we will take the 6 sections, we'll take them away. We'll then create a roadmap for the company. And you can see there, that's how these will generally look. I've shown an example there that fills all the gaps. That is certainly not the intent. It just so happens to be in that instance. It's quite condensed. It's quite populated, and at the end of the day, you have the day job to do. There are other priorities, and you don't have unlimited funding, unfortunately. So we will always try and work with you to target where the priority focus should be. So as I say, day 1, diagnostic, day 2, road mapping session, and ultimately we get to the end of that process. We'll follow up with you a couple of weeks later, quickly review the roadmap and have some kind of agreement in terms of what comes next and what are the actions. And those actions can be company specific that they'll take on themselves, or it can be through partners and networks. I think, having been involved in a good number of these, and SMAS has done in the region of about 200 now, as a minimum, we feel that companies will have a better understanding of how Industry 4 technologies can impact their business. But also, it helps, relay some of the myths around Industry 4, like, oh, it's really expensive, or it's overcomplicated, and you must deploy everything. And I think, that's one of the benefits of undertaking this process. It really puts some of these to bed, that that's not necessarily the case. I mentioned about some of the partnerships and third parties that we will use to help support actions coming out of your Industry 4 review. Here's just a quick example, and here's probably the main 4 areas. It might be SMAS coming back in for maybe an introduction to lean or some SMED changeover reduction. It might be our digital transformations coming back in to give you some impartial advisory support on implementing, say, ERP systems, or finding out more about some of the best practice that's happening in the marketplace. We may signpost you towards some of our partners in Scottish enterprise, such as sustainability or workplace innovation. But certainly more and more, we are seeing a real drive towards some of our external partners in the Industry 4 arena, such as Data Lab, NMIS, who are on the call today, and Census, for example, with sensors and imaging. And I think it's an exciting time for Scotland, for companies looking to embark on their digital journey. You'll see there is Scotland's digital ecosystem, which is constant. Every week there seems to be more and more services and options available for companies. So a real exciting time to get involved in lots of options. And as I've tried to highlight there, folks, for me, it's not just about the technology itself, but it's a range of support. And that can be skills and education, it can be infrastructure or collaboration on research, or in many cases, it can be funding through innovation and such like. So, as I say, that's a very brief overview of the Industry 4 review process. I realise we have a limited time today, so I'll capture any questions at the end, and hopefully we'll be able to update you then. And I'll pass you over to Richard.
Thank you, Tom, for that. I'll just pull up my slideshow. So I'm here today to talk to you about what Industry 4 is for manufacturing. Today, we can understand that there are challenges in manufacturing. You see below some themes running through it. It's obviously not an exhaustive list, but it's obviously some common challenges that are facing manufacturing today. Competing in global markets means shorter product cycles, reduced time to market, development cycles, and more customized products. Costs, we are looking at level of investment required for implementing digital technologies, acquisition of mature technologies, and also development costs through R&D. Applicability, so going back to something that Tom talked about there, is it a plant, process, or product that's deemed too complex or not suitable to Industry 4? Transformation, staff, which is really key. Upskilling staff with new skills to support deployment and maintenance of digital solutions. So looking at your software development practices, your implementation of hardware, etc., into your existing processes. COVID, which is obviously a key element at the moment. There has been a reduced demand for standard products, and companies are pivoting to support other requirements such as PPE. Brexit, increased costs and bureaucracy due to current free trade agreements. Climate change, obviously this is a massive national importance for Scotland at the moment, for the Scottish Government, looking at how we reduce the carbon output through net zero challenges and developing eco-friendly products and services. So you can see we've got quite a multitude of different challenges that are having an influence in manufacturing, and the question is, how do manufacturers respond to that, and how does Industry 4 support that? So what is Industry 4, also known as a cyber-physical system? It's the fusion of virtual, digital, and physical worlds. We want to, a cyber-physical system, which is something that is underpinning of Industry 4 themes, is about how do we manage and maintain a system through a network of connected devices that is able to continuously operate by adapting to internal and external influences with minimal human intervention. And this kind of theory came out of Germany back in 2009, and it really kind of founded the 9 pillars of Industry 4, as it were. So today I'm going to show what digital twinning is in a cyber-physical system. I'm hoping to show that this slide will provide an overview of how we compromise different elements that already exist today, and how we're using digital technologies to really pull these silos together. So if we start off on the left-hand side, current practices are that we use engineering tool sets and methods for computer-aided design, computer-aided manufacture, computer-aided engineering, such as CFD. We're starting to develop architectural solutions around building information management. There's some new concepts coming out through product design called model-based definition and model-based enterprise, and how we can apply those digital characteristics from a model into the manufacturing process. We have control systems, so control systems that operate automated machinery already. So when we saw in the advent of Industry 3 with more automation and robotics being implemented into industry, that we are controlling these systems through PLCs and SCADA systems, for example. And then what we're doing is we're creating all this already. This already exists, and we're creating and we're managing it through product lifecycle management tool sets, product data management tool sets. We're controlling the business through enterprise resource planning. So what can we do with that adds a little bit more content to Industry 4? So we can create digital standard operating procedures from the base, the original design intent. We can create digital work instructions that hopefully support the shop floor to allow operators and people to work in a paperless environment. Through the use of augmented reality and virtual reality. We can support training and development of people in a virtual content around these digital masters we've created. And then as we've created the digital masters, we really look at the next part of the journey, which is manufacturing everything. So we fabricate, we machine, we create, and then we build it all together, and we assemble it, and we install and we commission it, and we can use some of the digital content we've created in the previous silo to help us do that. We can create virtual PLCs to help us understand the operation of a system before it actually happens. And then all we're doing at this next part is just deploying it into that physical assembly. So you can now start to see that as we go through this journey that we are creating something that's built on a digital content, and we can set up what that configuration looks like at the design phase rather than building it through and making ad hoc changes based on what we see. So it really is trying to reduce the amount of costs and manufacturing planning and manufacturing execution at this point in time. And then we get into the execution phase. So we look at how we train staff, we look at how we operate the equipment in a friendly and safe and secure way. We understand what KPIs, what KPVs we are looking for within the process to understand the performance. And we do that through data acquisition, through whether it's through internal machinery data sets such as PLCs, SCADA systems, or if we are deploying external sensor solutions to monitor other elements that are not maybe intrinsic within the actual machinery itself. And then as we do that, we are creating data. We want to transfer that in a secure way, whether it's through Wi-Fi or low-powered networks or 4G or 5G. There's lots of different opportunities to do that now. There's within those network connectivity requirements. And another challenge is that, we have to really look at how we make that secure, that data set, because obviously as you create this data, it's something that's important to your process. So you really want to make sure that nobody can access it. And obviously we've seen over the last couple of months there's numerous hacks going on, and we can see earlier this week and last week it was Microsoft that got hacked recently. So we really need to make that data secure, as it were. And again, when we're doing that execution, we're utilising something that we've created at the digital master stage. We've got our standard operating procedures, our work instructions. We are delivering content through hardware such as augmented reality devices or mixed reality devices. And then as we've created that data, we're now storing it, so we can send it to local servers on premise, or we could use a cloud solution using virtual machines. And then within these platforms, we can show that data on an IoT platform that's quite common now about how we visualize data sets. And then we can see that within the cybersecurity element that there's going to be some changes coming along with ISO 27001. The HSE, the Health and Safety Executive, are going to be deploying the manufacturers who deploy these types of solutions to really monitor their cybersecurity. So that's going to be under the operational guidance 86, as it were. And as we can see, companies will need to look at how they manage that internally within their business processes, which is a key requirement if you're going to be looking at doing this journey. And then feedback. So we've created something, we've designed something, we've created it, we've built it, we've assembled it, we've deployed it, we're running it. We have all this data coming out of it, we're storing it. So what do we do with all that? So we've got all this additional information. So how do we visualize that? You know, how do we make it, how do we make data, how do we add content or context to data to turn it into information so that we can make quicker business decisions on that, and we can use analytics around machine learning and AI to really understand what the possible trends could look like, and then look at predictive opportunities to improve the operational condition of that system with the minimal intervention and minimal downtime. So it's really building upon that kind of total productive maintenance strategy you would have within your manufacturing environment. And that's already, we can already see that those sort of systems already exist around manufacturing execution systems or condition monitoring systems as well that have kind of been around since Industry 3. And what we're really trying to see here is we're building upon or on top of what's already there. We're just doing it in a much leaner way. So I just want to showcase a couple of examples of what I've just talked about. So one of our major research programs within the AFRC is the Future Forge. And we have been designing this for a couple of years now, because it's a big research program. So we've had our new facility designed. We've taken those BIM models from the architect and placed it in a virtual reality landscape so that we can understand how to factory facility plan it. And then as we've done the facility planning and the design has matured on the key functional elements of that, we can deploy those OEM CAD models into the virtual reality building, and we can position that as per the layouts and the drawings of how we intend it to look like, and we can maneuver and position that if there's going to be clashes around, you know, people walking around. And you can see in the bottom left here, we've got the big robotic manipulator, we've got the furnace, we've got the press, we've got the control station there for the operator to run the machine as well. So we've actually already started to really plan and really start to help with the training and development of staff to use this machine. And as we've done that, the next phase we've just completed is we've looked at the machine kinematics and the physics of those machines based on materials, weights, etc. Operations of the equipment, and really looked at how we could provide a lifelike simulation into that facility to give a much more greater context to the person who's working in there and that VR content. And we can see that we've got different views within the VR scene where we've got training and operation requirements being done. We can see we're starting to train based on what the commission system actually looks like now, and we're using a method of hardware in the loop where we are creating or connecting the physical joystick that's going to be in the control center for that trainer to operate the robotic arm in the VR cave that we have. So we're really trying to integrate physical hardware into a virtual scene to enable that training and development. And that's where we are with the Future Forge. The expectation is that that's going to be finished commissioning at the tail end of this year, with first operational trials going live next year. Obviously, COVID's had a bit of an impact on the actual development of it, so and the implementation and the commissioning of the system. So a second digital twin project we've worked on recently is the cask filling within Scotland. So we look at our whisky industry and how we can improve that using digital technologies. So we collaborated with industrial partners at Diageo, Siemens and KigTech in an Innovate UK project to see how we could improve the filling process for whisky. And the challenge was to look at how we could remove inconsistent filling processes. So we had to make sure that we were removing overspill, underfill and foaming by looking at real-time data on the fill volume and also looking at how the process works much more in depth. And I'm just going to show you, the next slide is just going to go in a bit more detail on that. So the key requirements: accurate and repeatable fill. We want to minimize the air pocket at the top of the barrel. No overfill. Obviously, overfill is a big issue with tax requirements for the filling of whiskey into the barrels. There was no flexible hoses were to be utilised at all. It had to be easy to use. The target fill time for an ASB barrel, so an American Standard barrel, which is about 200 litres, is 60 seconds. It had to be suitable for an ATEX environment. And the other thing that's really important to add here is that the casks are not uniform. So every cask is stripped down, it is rebuilt, it is charred, it's all handmade. Any new cask that's provided, it doesn't come as a cask, it comes in as separate individual components, then it's assembled within the cooperage. So every volume inside that barrel is inherently different. So what we wanted to do within this project was look at how we could remove that inconsistency within the process as well. And you can see on the right-hand side here, this is what our final product design or design of the test rig that we built within our factory looks like. Well, on the right-hand side, we have the physical world. What is the actual machine, as it were? What is the test rig? What is the production system? So we start at the bottom with the plan of the machine. We have actuators and sensors that can control the process and the physical devices. We have remote I/O servers and control devices that connect to our physical assets and actuators and sensors to control the process. And then that remote I/O layer goes back into the automation system, which is the PLC. And the PLC is operated by the operating system, which is PCS7. And then what we're doing is we're sending all the data into the cloud, into a database to record all that. But in our digital world, we can see we've got some different elements in here. So at the bottom, we're really looking at how we simulate the plant behavior. So we used a package called AmiSim, which helped us to understand the hydraulic flow of the fluid going through the actual mechanical design of the physical test rig. So we're using that to understand quite exactly, with regards to the pipe runs and pipe bends, what the fluid process is doing, i.e. what the speed is, what the pressure is, what the pressure drop is across the control valves and the flow control valves. So we really are getting an in-depth knowledge of the process before we even started doing anything. And then we're using a sort of integrated package here that allows us to connect the the CFD, the hydraulic analysis, into a platform called SIMIT, which is a simulation of the drives and the signals that the actuators and the sensors will look at within the physical system. So what we really are creating here is a digital entity of our physical assets that control the process. And what we can do with that layer in the SIMIT is we can then start to look at how we develop the control of those systems. So similar to your automation system, your PLC, we can create a virtual controller, which is effectively a virtual PLC. And we can either do that through software in the loop, or we can do it within hardware in the loop. So with hardware, you're physically buying a piece of hardware, and you're basically connecting that to your SIMIT platform, which is your virtual signaling condition for your actuators and sensors, or you can create it with software. So we went with the software route at this point to really look at how we create a virtual PLC to control our drives and signals, which controls our fluid flow within the physical, or within the sort of CFD analysis. And then at this point, what we see here is we've effectively created a virtual PLC, a digital PLC. And then the next point, you can see at the HMI level is exactly the same. So what we are effectively doing here is everything you see below the PCS7 operating system, everything's digital. And it's a representation of what's going to happen physically. And then the intent is that PCS7 operating system is effectively the real thing. Those two things are exactly the same. And then what we do is we effectively drop our digital entity from the PCS7 layer all the way down to the simulation of drives and signals. That is a complete digital twin of our physical world. And then all we're doing is, when we go to the installation and commissioning phase of the physical assets, all we're doing is dropping an image of our digital twin into our physical system. and we're able to start running tests and trials and commissioning and installation of that physical system. And then all we're doing is sending data into the cloud, which is exactly the same as the physical world. The results from that process, we were able to achieve a 5% improvement on industry standards with better than 99% fill on a 200 litre cask. We reduced the cask fill cycle time by 33%. So we went from approximately 60 seconds down to 40 seconds. There was no filling, there was no underfilling, there was no overfilling. So it was a highly repeatable, highly accurate process. And the impact of that is that there's potential to save the whisky industry millions of pounds each year in logistics, warehousing and inventory costs. When you think about a 5% improvement on industry standards, so we're going from 94% to 99%, that works out about 12 litres per cask. When you have approximately 8 million casks across the site of a big plant like Diageo, you're looking at about 96 million litres of whisky. And the other major impact we have is we've provided a new product and service offering for KigTech, the SME. They've now got a solution that allows them to, sort of challenge other industry areas that they've not had the exposure to already. And just to go back to where we talked about the silos with digital masters, the physical masters, the execution, storage, feedback, etc. We can see with Future Forge, we're almost at the point of where we're starting to do the execution. So we've done the training, we've created everything digitally. We're now going to drop that into the execution phase to really start understanding what we've designed and what that looks like in the physical world. And then with the cask filling system, we can see that we're now at the point of where we're creating feedback. We're visualizing data on the cloud. We're going to start applying data analytics to start looking at trending information of the physical hardware. And then really what we need to do at that point is look at how we create a loop, a closed feedback loop to operate the system with as minimal human intervention as possible. And that's me, so I'll pass over to my colleague, Grant.
Thank you, Richard. So I'll just start sharing my screen again. There we go. And just to double check that's coming through for everyone. Yeah, that looks to be. So I'm really glad that Richard went into such great detail there, because my talk's going to be a bit more high level, but I want to talk to you about two things. First of all is the AMBATS project that I'm running, but then also how are we applying some Industry 4 to additive manufacturing. So the AMBATS project, its full title is the Additive Manufacturing Business and Technology Support. It's an EU funded project and it's moderated through Scottish Enterprise. So NMIS are the lead research institution on this, and
we can't see your slide. Can you put that up at all?
Oh, okay.
Unless it's just me.
Let me reshare. Try that one more time. How's that for everyone? Is that coming through now?
I can see that now. Just need to put it on full screen. Perfect.
Okay.
Thank you, Grant. Sorry.
Apologies about that. Thank you very much, Laura, for bringing that to my attention. Yes, so Stephen Fitzpatrick, who unfortunately can't be here today, is principal investigator on that, and I'm the project lead, and this project's running until December 2022. So the project is aimed at SMEs located in Scotland. So we have three criteria, so located in Scotland, SME, and the adherence to horizontal themes. And if you follow this little web link here, you can find out more information about that. Just briefly looking at what we are offering within this project, there's a number of different support packages ranging from product suitability through to factory cell setup and process validation. But these are just a kind of overview to show you an idea of some of the things that we can help you with. But if you've got some challenges with additive manufacturing, my contact details will be there at the end, and please get in touch and we can discuss how we could work together. So how are we applying this in additive manufacturing, the use of Industry 4? So just very simply looking at a kind of standard manufacturing process, going from design to manufacture to use. We're drawing down on a database of information to inform how each of these steps happen. And this is very traditional and how we've been working for many years. But as Richard went into great detail explaining there about feedback, what we're now looking at is the information coming out the back end of design, so FE simulations, manufacturing, so process monitoring, and use, again, monitoring systems when parts and products are being used. And then we use this for continuous improvement as a feedback loop. So looking at kind of the landscape of digital age manufacturing, what we can see in this diagram, if we start up the top left here, we're looking at that everything has a commercial driver behind why it is designed and manufactured in the world. And taking you through the process here, you have your design processes coming out of that. And once you've got a finalized design on that, you can then start to look at building together your design FMEAs and your process FMEAs. And these can create for you your digital twin, which encompasses your process twin, your asset twin, so how you manufacture it and what are you manufacturing. Then looking at the actual manufacture of this goes out into the OEM marketplace. It goes through its product life cycle, and then it comes to its end of life. So in the circumstance where there's no option to recover the asset, you're looking at your recyclability pathways here, and there's various different ways that can go. But in the best circumstances, we're looking at how do we recapture this resource and pull that back around full cycle. You've also got repair and recondition, where you can pull this back through into a resale market and retain these assets. But what we're really interested in is remanufacturing. So really understanding why have components failed, and this builds into our knowledge database. Now, to get back round through into this loop, we really need to rely on digital twins. So how was it manufactured? What was it manufactured from, etc. And that is the pathway to pulling this back around into the full loop here. Is that going on the slide? Yeah. So when we're talking about digital twin, I hinted on there at the asset twin and the process twin. But digging down into much further detail on that, we also have a manufacturing twin and also a performance twin. We could go into much more detail looking at all the different aspects of this, but the main part to really consider and take stock of is those 4 components there that build up the digital twin for us. When we're looking at the additive manufacturing process, we've categorized it in these 6 main components. So design and simulation, manufacturing planning, pre-processing, the actual manufacture itself, and post-processing, and then buy-off and validation. Now, you can see that we've got a loop system going on here in terms of inspection and validation. Now you can imagine that all the data that is generated from this then leads up into how you get parts certified at the far end of the scale here. So David Hardacre from Lloyd's Register has done a really good diagram to kind of summarize this as part of the CLAIM project. And this is looking at powder bed fusion process mapping. Now you can see various different points along the way where all this data is being created, such as powder characterization, so the material that you're pulling into the system, process monitoring, and all your destructive and non-destructive testing, that once pulled together at the end of the day is the pathway for then having these parts certified. Because without this data, it's impossible to have these parts certified because you don't have the information to do that. So I'm going to do a quick case study here looking at a project we worked on called Digital a couple of years ago now. and just looking at that process that we're talking about there, from design to manufacture to being used to its end of life. So this was a closed die hot forging tool, and you can see that after 1,300 parts, the die had worn to such a point that it was now no longer conforming, so it had met its end of life. So just looking at some of the basic information coming out the back end of that, of what we've learned or what we knew, is that we knew what the tool material was, we knew what the process was. We now knew that the amount of parts before its end of life, what the failure mode was from looking at analysis, and also we know what the lead time was for the part being manufactured. So if you look at this just in a very simple way, from the start of operating, you need to work back the way to obviously order your dies or your tools so they're there in time. But then to ensure that you've got continuous operation, you then need to think about, right, well, when would I need to order my die to then have it there for continuous operation? So very simply, just looking at what the lead time was minus the life expectancy, and then putting a small buffer in there. So this is where you can start to then take on board a lot of what Richard was discussing in terms of all the data that's being driven. And if we had an automated system for ordering your tools that you need, you could get that level of operational certainty. If you're working with complex supply chains, which are being made even more difficult by Brexit, and now you can start to imagine if this system becomes even more complex, because this is a really simple, basic one that I've put here, how do you actually do this and make sure that you have everything you need in the correct time? And then a lot of this can be helped and assisted by process monitoring. So what we were doing in this project was looking at remanufacturing the die. So this is our little diagram that we use for a decision matrix about using remanufacturing. And what you'll see as we go through this, that a lot of it is really relying on the digital twin, but also how a lot of this creates a feedback loop that then informs your digital twin. So when we start to look at this, we look at doing a recoverability analysis, and the very first thing we ask ourselves, is there a 3D CAD available? And that's where we would look to obviously the digital twin for doing that. There are other ways and means that we can do that. So do remanufacturing, so we can start to look at, can it be re-engineered? But obviously that comes at a cost, so we need to look at that as well. But there's also the ability to create composite digital twins. So this was actually something we did in a different project where we didn't have the exact CAD data that we needed for the product we were working on, but they had a similar model to what we were working on. So we used a combination of a 3D scan and CAD data from a different model, combined them together, and that enabled us to work on that. But moving through this process here, you can see that the first thing that we do is update the failure mode effects analysis with what the failure mode of the component was. So in this circumstance here, it was to do with wear. We then start to look at the different remanufacturing technologies that are available. And now we update the process FMECA, saying what the new manufacturing process is going to be. So obviously this all comes at a level of risk. So there is the ability to reject or accept. But in the circumstance where we do accept this and we move through to remanufacturing, we then start to look at doing validation through metrology, non-destructive or destructive testing, etc. And then that all feeds back to a specification check. But you can see at many of these points here that we're actually generating new data that's going back into our digital twin. And based on the previous diagrams that we showed you, this is how we can have that continuous improvement and that feedback loop going back to the designs and products that we're manufacturing in the very first instance. So just showing you what we did in this project. We had the the design, the manufacture, and then the use, and we came to the point at which obviously the part was now out of scope. So what we were able to do is 3D scan the worn die, compare it to the original CAD design, isolate the areas of wear on that, machine these back, and then we were able to use additive manufacturing to build back up material. And then that's what that looks like. And then using, again, the original CAD data, machine back to a conforming geometry. And then we were able to enter this back into service life. So this is how that goes back through that loop that I showed you earlier on of retaining assets. And obviously at some point that will wear down. So I've got a little video here just showing you that exact process, because I'm sure it'll be of interest to some people here. So like I say, we machined that down first of all, and then what we did was we then applied, interestingly, a different, more hard wearing material in the areas of wear, as you can see there. And there was a few different parts where it was worn, so we remanufactured those areas. And then we should see at the end here, once this part's finished. Oh, okay. This video is just the additive, apologies. But then after that, we remachined it. So what does this kind of look like? So we knew that the original die would manufacture 1,300 components before it met the end of its service life. So that served as a benchmark really for what we were doing. So we could say then with the other dies, we could pull them out of service after 1,300 components, remanufacture them. And what we found when we did this and put this back into service was that we were able to manufacture an extra 1,400 parts, which extended the service life of the die by 108%. And that brings me to the end of my presentation, and we've now got some time for questions. And I believe Kwaku has been monitoring the chat for questions. So Tom and Richard, I don't know if you want to pop your cameras back on.
Yeah, back
so
on, Grant.
Excellent. So Kwaku, have we had any questions put forward?
No, we don't have any questions yet.
Okay.
But I'm sure they'll start coming in.
Yeah, well, I mean, if anybody's thought of any questions they would like to ask for any of the presenters, or questions you'd like to ask all of us, this is a good opportunity to do so. So, I'm going to start things. Tom, I'm going to ask you a question. The assessments that you talked about. What's the best way to organise one of these?
It's fine, Grant. If somebody gets in touch via the email or the links that have been shown today, we have a regional team of practitioners across the country. So, if they come directly to myself, if it's in the West or the South, myself or one of our team will follow that up with the company. If it's in the North or in the East, we'll pass that to the relevant practitioners, and they'll do it likewise. They'll make direct contact and then arrange a call or a meeting or whatever's suitable to the time and place. Okay, brilliant. So essentially, no matter where you are in Scotland, there's a team ready to help you out with that. Yeah, and it's the same, when the guys in the North team or the East run events as well, they'll redirect some that come across to the West. So although we're on a regional basis, it is effectively one team. Good.
All right, Grant, we have a question here, and it reads, regarding the digital twin, how important is the creation of a digital building and assets to the roadmap of existing technology, of old equipment that does not require redesign or training purposes?
Sounds like a very good question for Richard.
Well, I guess when we look at the challenge around sustainability and environmental impact of manufacturing into what's going on. So hold on, my son's just joined me. He's showing me something. Yeah, apologies about that. So, I mean, you really want to kind of understand what your manufacturing footprint is doing with your, your environmental impact. So that could be one way of looking at it. Technically speaking, there is no like right answer. I guess it's more to do with the business and the strategic direction that the business wants to go in, and how much detail you want to get to within your sort of digital content. If it's purely just looking at 2D visualization of data sets from machinery, that's perfectly acceptable because it gives you much more visibility of the manufacturing process far more remotely, and allows you to make decisions on your business much faster. So it's really it is dependent on the business itself.
Okay, thank you for that, Richard. And I have another question which came to me. So this is with regards to digital twinning. Whose responsibility is it when we are talking about things about cybersecurity? Is it the one who is being transformed, or they have to? It's expected of the regulator. Thank you.
It's the expectation of the HSE for the business who has got access to internet access points to be able to show that they are cyber secure, and that's what will be rolled out in what I believe in the next 12 to 18 months.
There we go. Do we have any more questions, Kwaku?
I'm still monitoring, none have come in yet, but I'm sure they are probably typing it in.
Okay. Let's see. Maybe what everybody wants to know, Richard, is did you get any whiskey during that project?
No, I did not get any whiskey. Unfortunately, if you get whiskey on your site to do testing, you become a site of interest to the HMRC. And I'm not sure anybody in their right mind would like to become a site of interest to the HMRC. So traditionally, though, when you look at cask filling solutions in particular, or just disgorging solutions, industry organisations that do that kind of stuff always test on water first before they put their site onto the actual distilleries. Factors.
Makes sense.
They always test on water because the fluid properties of water and whiskey are quite similar at room temperature. So they are. So it's you're getting an almost like for like test.
Yeah, because it's not an overly viscous liquid.
No.
It's got quite nice flowability to it. Can't drink a digital twin either, can you? Unfortunately.
All right, Grant. So this one for you. It reads. So in your presentation, you mentioned about digital assets and digital process. Would access to either of them be? What's that? Would access to either of them pose a risk if they are not used together?
Yes. So I think a good example of that would be both in the video that I showed and also Richard's CAD models he had of the future forge. If you don't take into consideration everything that's in the environment, then this is where you have the risk of collisions occurring. So a good example would be we have a CAM software that models the process when we are doing laser metal deposition for the remanufacturing. Now, it only really considers the CAD model it has in front of it and what it's doing in relation to that. After we've put it through CAM to make sure that the tool paths, etc., are correct, what we then do is put it through a verification software called Vericut. And what that does is it considers the full environment that we're working in. So not only does it have the nick and rotary table that you saw the tool mounted on, but it has other different parts of the machine within there. So it's a full virtual environment. And then what it does is it takes the CAM process and ensures that there's not going to be any collisions. So for instance, the nick and rotary table also has a tailstock. So when the head is down and moving between operations, so rapids, we need to make sure that that toolpath doesn't cross the boundary of something physical within there. Don't know if you'd want to add anything more to that, Richard.
No, I think you covered it fairly well there.
Okay, good. So I think we'll just do.
I think this last one.
Oh, yeah, perfect.
Yeah, it goes for Tom. So this is mostly about if one party undertakes digital transformation and other members in the supply chain have not done that, how does it affect the productivity? Because I think he talked about benefits if you digitalize your supply chain.
Yeah, it's a good point. Whoever's raised that question, and timing's everything. We had an example, a company I was out at last year, just before the lockdown, some fantastic ideas in terms of what they could do in-house, and they were looking to kind of see the benefits into their supply chain, but unfortunately, some of the customers and some of the suppliers weren't ready for it. So it's that, and I think that's why you have to look at the whole value stream when you're doing this, in terms of how does it fit? Is it something we're going to do locally? Is it an opportunity to go supply chain? And perhaps the first point in that process is to talk to some of the folk in the supply chain, and maybe there's an opportunity to collaborate and share information and share changes at the same time. But it's certainly, I would definitely not advocate acting in isolation as the person's asked, because if your suppliers and potential customers aren't ready to make that change, then it's back to that technology for technology's sake in many cases.
Good.
Okay, thank you, Tom. I think, Grant, that's all for now.
Okay, excellent. Yeah, I was just going to say, I think we'll wrap up questions there. And what I was going to do is just point people on to more information about both the National Manufacturing Institute Scotland and the Scottish Manufacturing Advisory Service. If you're wanting to get in touch with NMIS and you're wanting to speak directly about anything to do with the digital team, Sam Hume is the Business Development Executive for that team, and his email address is listed there. And in my team, the Additive Manufacturing Machining team, you've got Barry McGee, who will be able to speak to you, and you can get in touch direct with Tom, and his email is listed there. So thank you very much, everyone. I'm going to pass over to Debbie now for some concluding remarks.
That's great. Thanks very much for that, Grant. Just like to thank you all for joining us today for our NMIS Insights, and just to say thank you to Tom from SMAS and Grant and Richard from NMIS for great presentations. Thank you. Just going to bring the webinar to a close now. Thanks very much, everyone.
Thank you.
Thank you.
Thanks, folks.
Thank you, bye.